Okay, let's graph some more complicated sine and cosine graphs. So on this first one, we have 3 sine of pi over 4 times x minus pi over 4. So what's going to go on here is we have a phase shift affecting this graph. It's going to be moved either left or right because we have a number being added or subtracted directly from x on the inside of this sine function. All right, so some things to get going on this. First of all, this 3 out in front, that's going to affect how high up the graph goes. So we can say that's the amplitude. It's going to go up to 3 and down to -3. So that's kind of a label on our y-axis. This one has not been flipped upside down. So it's the typical sine graph that starts at the origin and begins up first. All right. Next up, this pi over 4 times x minus pi over 4 on the inside here. Let's go ahead and just rewrite this quickly. And I think that'll help us out. If we factor out a pi over 4, that'll leave us with x minus 1 on the inside here. And what that allows us to do is see this pi over 4, that's going to affect the period. But this minus 1, that's going to be that phase shift. And when you're subtracting 1, that means everything's going to move to the right 1 unit. All right, so let's think about our period. Our period can be computed as the original period for sine, which is 2 pi, divided by this multiple attached to x, or this multiple that we factored out, the pi over 4. So I'm going to say 2 pi divided by pi over 4, which is equivalent to 2 pi multiplied by the reciprocal 4 over pi. In this case, we are allowed to cancel out the pi's. This makes a 1 when you're multiplying by pi and dividing by pi. So the period here is actually going to be 8. It's going to take 8 units from left to right before we repeat into our second period. All right, so our labels at this point on the x-axis, we go from 0 to 8. Halfway in between is going to be 4, halfway between 0 and 4 is going to be 2, and halfway between 4 and 8 is going to be 6. So we've applied that change in period for our labels on the x-axis. Now the other thing is this phase shift. So next, let's apply this phase shift. So we want to move all of these labels basically to the right 1 unit. So what I'm going to do is I'm going to add 1 to each one of these labels the whole way across, and those will give me my labels for the x-axis. So when we have 0 plus 1, we're going to start at 1. Then we have 3 as our next key value, 5, 7, and 9. Just kind of labeling the x-axis using these exact same labels that we would compute after the phase shift. All right, the only thing that remains is to draw our graph in. So you can kind of say, well, we've got these labels. Those are kind of corresponding with these key values as we look through this. So I'm just kind of putting some points on there as reference marks. So I'm going to start at 1, go up, highest value there at a y value of 3 and an x value of 3, back down all the way down to 7, -3. And to complete that first period, we're going to end up here at 9. That's the 8 plus 1 makes 9 here. All right, I hope this helps on the graphing this one with the phase shift. Let's take a look at one that has just a little bit more going on. We've got a phase shift on this next one as well as a vertical shift. So as I take a look at this, there is a lot going on with this one. All right, this -2 out in front, what that's going to do is that's going to affect our amplitude. The amplitude is technically the absolute value of -2, which works out to be 2, which are going to be labels on our y-axis typically. So normally what would happen here is we go between -2 and +2 on our y-axis. However, this one has a little bit more going on, that we have a vertical shift. So this +3 is moving everything up 3 units. So what I'm going to do with my labels on the y-axis is I'm going to add 3 to each one of these. So my new labels on the y-axis are going to be at 5. It's going to go up to 5, and then -2 plus 3 is going to make +1. So this graph is going to oscillate between +1 and +5 on the y-axis. We'll go ahead and label that as we take a look at this. Okay, so we have a vertical shift up for 3. the other things I want to take a look at are what's going on the inside here. All right, so on the inside there, I'm going to do just a little bit of factoring first. So we can say -2 times the cosine of pi over 2. I'm going to factor that out. And what that's going to allow me to do is see my phase shift a little bit better. So on the inside here, I know I have to have an x, so pi over 2 times x makes pi over 2 times x. But then I also need to think pi over 2 times what is going to give me a pi. So I think if we go ahead and say, well, if I just add 2 on the inside here and think about redistributing, what's this going to look like? Pi over 2 times 2 is just going to give us pi back. What that helps us with is the phase shift. So all I've done is I've rewritten our original function here by factoring out a pi over 2 on the inside. All right, so the period in this case can be computed by saying the original period of cosine, which is 2 pi, divided by that multiple attached directly to x on the inside, that pi over 2 that we factored out, or the pi over 2 multiplied directly by x on the inside. And this computation is equivalent to 2 pi multiplied by the reciprocal. So I'm going to multiply here by 2 over pi. And what that's going to do is we can simplify down by saying we're multiplying by pi and dividing by pi. Our period is going to be 4. So that means 4 units from beginning to end. So 0 to 4. And again, I'm going to include some inner labels here. So halfway in between is going to be 2. Halfway in between there is 1. And between 2 and 4 makes 3. So that's applying the change in the period so far for our x value labels. But then we also want to include this horizontal shift, this phase shift. Okay, so the +2 here, this is a phase shift that moves everything to the left 2 units. So what I'm going to do for each one of these labels is I'm going to subtract 2 from each one of them. And then those labels are going to go on our x-axis because that's all the transformations that we have to apply. So we've gone to the left 2 units. So I'm going to begin at -2. So -2, and then 1 minus 2 is -1. 2 minus 2 is going to be 0. Another key value here in the middle. 3 minus 2 makes 1. And 4 minus 2 is going to make 2. Now that I have everything labeled, let's go ahead and kind of get started here on putting it all together on a nice graph. Now you may go ahead and say to yourself, well, between 1 and 5, our midline that would go straight through the middle of our graph here is going to be at 3. So that may be a handy label to include as well. But remember, what's going to happen is our cosine graph has been flipped upside down. So instead of starting at the top, it's going to start at the very bottom. And in our case, that's going to be at -2, +1. It makes it to the middle at that next label. It makes it to the top in the middle as 0. Back down to the middle at 1. And then back to the bottom at 2. So I'm just kind of including a few points along the way at those key values that we've labeled on the x-axis. All right, so we go up. Reaches the top here. Comes back down. And you're going to finish up here at the bottom. All right, so it's not the prettiest of graphs. My artistic skills are not perfect. But as long as we label everything, that's going to be a big key as far as getting a good graph going on these and understanding how attaching numbers in different places is going to affect our graph. So I hope this helps clarify as you're trying to graph sine and cosine functions with a bunch of transformations. Good luck.